Alright, so we successfully completed this first stage. We've got moles of FeF2 at a number of, a calculated number of 0.101 moles of FeF2, and that becomes our new starting amount for this stage of the problem. Okay, so I'm going to go down here and put 0.101 moles of FeF2, and since that's our new starting amount, I'm going to put it over 1. Alright, so to go from moles of one species to moles of another, we need a molar ratio. Molar ratios have to come from the coefficients in a balanced chemical equation. Okay? So I haven't written a balanced chemical equation yet. So I need to do that to get our molar ratio. And that is going to go in this stage here. So let's see, our starting amount is, or our starting species is FeF2, that's one of them anyway. And the problem said that we are reacting it with calcium chloride. Okay, so I need to list calcium chloride as our other reactant. And what I have to do now, since we've done this in Unit 5 and we've learned to predict the formulas for chemicals in Unit 4 and Unit 3, we're ready to predict the products of this reaction. Okay? Now, first thing we need to know is what kind of equation it is, what classification of equation this might be. Yes, it is. It's double replacement, and you know that. And there are two ways to know that you have an ionic compound, and both of these fit one of those two ways. This is a metal bonded with a nonmetal, and another metal bonded with a nonmetal. So both of these are ionic for that reason. Okay. The other kind of compound that you recognize as being ionic is one that contains a polyatomic ion, which you use your common ions list to figure out. All right. So if I have two ionic compounds, or even if I have an acid in an ionic compound, you're going to predict a double replacement reaction. And in a double replacement reaction, the front part of this compound is going to join up with the back part of that one. Okay? So Fe is going to go with Cl. I haven't balanced that formula yet. I'm going to wait to balance that formula. Okay? Now I'm going to take the front part of this and put it with the back part of that. So calcium is going to be put together with fluorine. Alright? So what I need to know is, do I have a driving force? That's the first thing. Okay? So I need to know if this is going to form a solid or water or gas. Well, I don't see any obvious gases. There are only a handful you need to know about, and none of those are here. Water's not here. Water is H2O or HOH. So the only possibility of a driving force is going to be the formation of a solid. For that, I need the solubility rules. All right, so chlorides, my solubility rules tell me chlorides are mostly soluble. So in water, they would be aqueous unless they're bonded with silver, lead, or mercury. Well, this isn't silver, lead, or mercury. So this fits the rule, and so this is going to be aqueous. Okay, and then fluorides here, it says are soluble. So in water, that means they're going to be aqueous, except when they're bonded with group 2, lead 2, or iron 2. Well, calcium, it turns out, is in group 2. It's in the second column of the periodic table. So a group 2 salt of fluoride is not going to be aqueous. Since it's an exception, this is going to be a solid, and there's the formation of a product that's going to give us a driving force. Okay, so now we're ready to do all the other stuff we have to do. We have to look up the on the solubility rules and find our physical states for FeF2, and that is going to be aqueous. And calcium chloride is going to be aqueous, using that same set of solubility rules. Now we have to balance these formulas. Okay, we're putting together iron and chlorine here. And chlorine has a 1 negative charge. That's because iron has to have some kind of positive charge. Let me show you that. Okay, iron has to be either 3 plus or 2 plus. Okay, well, since I have two fluorines here, and fluorine also has to be 1 negative, that means this iron has to be 2 positive. If it's 2 positive here, we're going to assume it to be 2 positive over here too. Does that make sense to everybody?
Yeah.
Do I need to go over and show you why I know it's 2 positive over here? Yes or no? Everybody's cool with that?
No. You didn't show me.
Alright then. Fluorine only has one kind of charge. It's a negative. Alright? I've got 2 of them. When I break it apart, this 2 means both these fluorines are bonded together and with this iron. When I break it apart, we don't have them bonded together, so this fluorine now has 2 fluorides. And we have 1 iron. Okay? Since I know that I only have 1 iron and 2 fluorines, I know that I have a 1 negative charge here that I multiply by 2, and I add it by 2 some charge that I don't know yet when I have a 1 here. So to get the whole thing to equal 0, this charge on the fluorine must be a 2, so we put a 2 plus here. Okay? That's how we know it's a 2 plus. Okay? So this is also going to be 2 plus. We'll assume it to be in this class anyway. Okay? Alright, so if the iron is 2 plus and the chlorine is 1 negative, using this same sort of math, 2 plus the 1 negative, 1 negative. We want the whole thing to equal 0 when we're done. This must be a 1 here and a 2 here. So we need 2 chlorines. And so what we're going to do is when we bond those together, they're separate right here. When they get bonded together, you use a subscript to show that. Okay? Calcium is always 2 plus. Fluorine we already said was 1 negative. So this is calcium and 2 fluorines. Now we're ready to do an atom inventory and balance the equation. So we're going to write Fe, F, Ca, and Cl. An atom inventory, we're making a kind of grid or spreadsheet here to count up all of our atoms. Got 1 iron and 2 fluorines, 1 calcium and 2 chlorines. Turns out we have 1 iron and 2 chlorines on this side, 1 calcium and 2 fluorines on this side. So we can see that it's already balanced. We don't have to do anything else then. This is already balanced. That's done. We're ready to go on then and make a molar ratio. The molar ratio comes from the coefficients in the balanced equation. Every time we build a conversion of any kind, we want the bottom of this part of the problem to have the same units and species as the top of this part of the problem. So I know that I need to have moles of FeF2 here. The problem is asking us to find the amount of calcium chloride. So I need to have the moles of calcium chloride on the top, because that's what I'm trying to find here. Okay? In this case, in this problem, in this balanced equation, there's a 1 to 1 ratio. So our molar ratio is going to be 1 to 1. So we're going to cancel moles, going to cancel the FeF2, and we're ready to calculate the number of moles of calcium chloride, which is what we said we needed to find in this stage. Okay, and that is 0.101 moles of calcium chloride. Okay, no rounding needed because our final answer has the same number of digits as this calculated number. Both of these are counted numbers. We ignore those when we're figuring out significant digits in multiplication division. It's the only one that matters, and this is what the answer we're going to get. Okay, so that's our answer in this second stage of the problem.